Hello, good day viewers. I saw this interesting question on Isomnofo's channel where he solved exactly the same problem using synthetic division. So in this tutorial, I would like to show you how you can solve the same problem using long division. So the question is, the remainder after dividing negative x cubed minus 2x squared plus kx minus 4 by x minus 2 is negative 2. We're asked to find the value of k. So what does it mean? It means that if you take this expression here and divide by this, the remainder will be negative 2. So let's see. Let's divide this by this and obtain the remainder. And the remainder will have to be set equal to negative 2. So using long division, we have negative x cubed inside minus 2x squared plus kx, then minus 4. This is what we have inside. Remember, our quotient will be here and the divisor, which is x minus 2, will be outside. So to perform long division, always take a variable, plug it into the variable. The first term here, always use the first term and the first term. So how many loss of x can you find in negative x cubed? It's just like taking negative x cubed divided by x, which is going to give us negative x squared, right? Then you take this value here, you multiply by these two terms. Negative x squared times x will give us negative x to the third power. Write it underneath, negative x to the third power. Then negative is positive. X squared times 2 is 2x squared. You draw a line and subtract. We are subtracting this from this. So some people might change these signs, but I prefer to do it like this. Negative x to the third power minus another negative x to the third power. So we have 0 here. We move to the next. Negative 2x squared minus 2x squared. That will give us negative 4x squared. It's just like attaching negative here. So we have negative 2x squared, negative 4x squared. Then you drop the rest. We have kx minus 4. Next, we repeat the same process. Take x, plug it here. You have negative 4x. Then that negative 4x multiplied by these two terms. Negative 4x times x will give us negative 4x squared. Negative is positive. 4x times 2 is 8x. You subtract. This minus this is 0, right? We are subtracting. But this minus this, that is, let me write it here. Kx, since we don't know the value of k, we cannot subtract directly. Minus 8x. This is what we have. But since we have x in common, we can bring the x's outside. Did you understand that? So it becomes x times k minus 8. Then you drop negative 4 down. You repeat the same process. X into the whole of this will give us just k minus 8. So we have k minus 8 here. Then you take k minus 8, you multiply by these two terms. K minus 8 times x will give us x k minus 8. Then that times negative 2, the negative 2 will affect every single term inside, right? But just, I think, let me just write it as negative 2 times k minus 8. So you subtract again. This minus this is 0. You move to the next. This is negative 4 minus 2 times k minus 8. So it becomes negative 4 minus. So we have plus 2 times k minus 8. You can see the last term does not contain x. So this is our remainder. So if this is the remainder, we're going to equate it to be negative 2 and solve for k. So let me come here. We have negative 4 plus, I'm going to use this 2 to expand. 2 times k then 2 times negative 8 is negative 16. The whole of this equal to negative 2. Yeah. Negative 4, negative 16 is negative 20. So we have 2k minus 20 equals negative 2. Take this one to the other side. We have 2k to the left equal to, as negative 20 crosses over, it becomes positive 20. We have minus 2 already there. This minus this is 18. So we have 2k equals positive 18. You divide both sides by 2. Have k equals 9. Simple. So therefore, the value of k in this problem is equal to 9. And you can plug it back, divide, and see whether you're going to get a remainder of negative 2. And also, if you like, you can test this k in here. So you can see k is 9. So we have 9 minus 8 is what? 9 minus 8 is 1. Then 1 times 2 is 2. Negative 4 plus 2 is negative 2, which is indeed our remainder. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.